Hello students, welcome to lesson 1.2, and we're going to talk about algebraic expressions. And remember, we're just doing a quick review of algebra 1. And it's an algebraic expression is a way of expressing how certain variables are related, mathematical expression, and kind of in a way of representing things that we don't know. So for example, if a problem tells you that 7 less than a number, well, if you had a number, right, let's say the number was 90, what would be 7 less than that number? That would be 90 minus 7. So, but in this case, we don't know the number, so the number, we're just going to call it n. So it's going to be n minus 7. Whatever the number is, minus 7 would be 7 less than that number. 3 times the square of a number. Well, you have a number, and it is squared, so that's x squared right there, and we're going to multiply it by 3. So that's why we get the 3x squared. The cube of a number increased, that's addition right here, by 4 times that same number, so 4p. So p cubed plus 4p. Twice the sum of a number and 5. Well, you have to be able to separate this part right here. The sum of a number and 5, that would be the y plus 5. And twice would be over here multiplying by 2, but notice the parentheses. Okay? Alright, in this table what we have is properties of equalities, and this is what allows us to solve equations. So we have a reflexive property right here. And basically what this says, if a is equal to itself, a is equal to a, like minus 7n is the same thing as, minus 7 plus n is the same thing as minus 7 plus n. Reflexive. Symmetric. Symmetric property says that if one thing is equal to another thing, then that other thing is equal to that thing. If a equals b, then b equals a. So if you say 3 is equal to 5x minus 6, then 5x minus 6 is equal to 3. Transitive. Transitive property says it's a relationship between 3 things. If a is equal to b and b is equal to c, then that means that that first a was equal to the last c. So you can literally set things equal to each other. So for example, if 2x plus 1 is equal to 7, and 5x minus 8 is equal to 7, and that means that 2x plus 1 is equal to the 5x minus 8. And this is the foundation of being able to solve 2 things that intersect, that are equal to each other at a particular point. And then we also have substitution. So we can definitely substitute values. In this case, what they substituted was the 4 plus 5. They wrote in a 9. But you've also seen substitution that once you know the value of a variable, you can go ahead and plug it in. We also have the concept of the addition and subtraction properties of equality. So for example, if we have x minus 4 equals 5, the fact that because they're equal to each other, if we add 4 to both sides, we have not changed the equality. And this is the most important tool for solving. We know those cancel, so we have that x is equal to 9. And we can also do the opposite. So if this had been x plus 4 equals 5, then we could have subtracted 4 from both sides of the equal sign. Right? Remember, if you are working here on only one side, then you're combining like terms. But when you're working on both sides of the equal sign, then you're doing this balancing act. Okay? This goes away, and we got that x is equal to 1. Alright, we also have the multiplication and division properties of equality. So this could be something like 1/4, oops, I have no ink. 1/4 m equals 2. And so how do we get rid of this? Well, we have to get rid of the 1/4, and in order to make it a 1, we have to multiply by the reciprocal of it. So we're going to multiply the reciprocal of 1/4 is flip it. So put the 4 on the numerator, the 1 in the denominator, so basically a 4. So you multiply both sides by 4. This whole thing becomes a 1, right? They cancel each other. And m is equal to 8, and that would be your answer. Now this can also happen if you had a multiplication problem, something like 3m equals 21, right? And so I think most of you guys would think of this as division or multiplying by the reciprocal. So that cancels and you get 7, right? Now, here's another way of looking at this, okay? 3m equals 21. We're going to get rid of the 3. How do you get rid of the 3? You use the inverse property of identity property of multiplication. What's the reciprocal of 3? It's 1/3, or the inverse. So you multiply both sides by 1/3. Same thing, see? This cancels, and you're left with just m. And 21 times 1/3 is 7, or 21 divided by 3. It's the same thing. I think this is just a little bit easier process. But when we have a fraction in front, it's just easier to get rid of the fraction by multiplying both sides by the denominator. Okay? Alright, here's an example that would, that some students get scared about because it's negative and it's also a fraction. But I mean, you just have to think about, well, how do I get rid of the 3/5? Well, you would multiply both sides by the reciprocal, which is 5/3. And in this case, you gotta make sure you include that sign. So you would multiply both sides by negative 5/3. It's multiplication, right? And this number, they're inverses of each other, so they cancel. And then D equals 18 times negative 5 divided by 3. And you're going to get 18. Negative 18. I just messed up my video. I'm sorry, I was looking at the wrong number. It didn't make sense. It's a negative 30. Okay? Alright, so we have a new example, and hopefully I'll solve this one without making a blunder. With this one, it's an equation because we have an equal sign. And we also have to use our distributive rule. So we have to distribute this 2 into this parentheses right here. And we'll get 4x plus 6. And we'll have to distribute this negative 3 into this parentheses. So we'll get negative 12x plus 15 equals 22. Alright, and before we do the balancing act, we have to focus our attention entirely on this side. And since we're staying on one side, that's combining like terms. Alright, so I don't want you to make a mistake of saying like, well, I'm going to add 12x here and then 12x over here. That is a no-no. You cannot do that. When you are working on one side of the equal sign, you are combining like terms. So think of it as, well, in this case, subtraction, because one's positive and one's negative. So 4x minus 12x. And you're going to get negative 8x. And then this 6 and this 15, they're like terms. So then you're going to get plus 21 equals 22. Now, nothing on this side. They're not like terms, so it's as simplified as you can get. So now you have to balance on both sides because you have a 21 on this side and a 22 on the other. So now, because you're crossing the equal sign, now you can do the balancing. So since it was plus 21, we'll do minus 21 on both sides so that we don't change the equality. So this goes away, and now we have minus 8x equals 22 minus 21 is 1. And then since this is multiplication, we can divide out the negative 8. And this goes away, so then x is equal to negative 1/8. And that would be your answer. Alright, this example goes into rearranging the equation before we would solve. So in this case, they don't give you values. They just say solve the formula for L. And they say that the surface area of a cone is pi times the radius. L is the slanted height plus pi times the radius squared. Alright, so I would start out by writing out the formula. Alright, let's see, pi r squared. And I'm interested in solving for L. So that means I'm going for this variable. So the first thing I would do is I would subtract this quantity from both sides. See that? Because I'm crossing the equal sign. That means this quantity is no longer on this side. And I have s minus pi r squared equals pi r L. And I'm still interested in this. So I'm going to divide. Since all of this is multiplication, right? I'm going to get rid of that pi and that r by dividing it out. But this is a quantity, right? It's a subtraction. So, think of it like a group. So you have to divide by, this division bar right here, fraction bar, has to make sure that you cover both the s and the pi r squared. Alright, they cancel here, and we're left that L is equal to s minus pi r squared, everything over pi r, right? If it's safer, do that. Or you can say L equals, and just kind of flip them, s minus pi r squared over pi r. That way you have the L on the left side, okay? And this would be the answer. Now, if you wanted to solve for L, you would need to know the surface area. You would need to know the radius. And the radius is here as well. And pi, we know what pi is. And if you knew the surface area and the radius, you could plug it in and you can calculate the slanted height. Alright, this would be an example of creating an equation and solving a problem, which is the main purpose of CC, of Common Core. You have to be able to write your own equations and then solve the system. Alright, so what do we have here? We have Josh and Pam have bought an older home that needs some repair. After budgeting a total of $1,685 for home improvements, so that's the maximum that they can spend, they spend $425 on small improvements. They would like to replace 6 interior doors next. What is the maximum amount that they can afford to spend on each door? Well, the variable here, the unknown, right, which we can call whatever we want, D, C, K, M, not sure what you would want to call it, but let's say X is going to be the cost of each door. Right? And we know we have 6 doors. So 6x would be the cost of 6 doors, right? Because when we multiply by 6, we have 6 doors. We know that they have spent $425 have already been spent. And $1,685 is the budget, or the money that they have. So the maximum amount that they can spend, the total amount of money is basically the amount of money that they can spend on the doors plus the $425 that they've spent, and all that has to be equal to $1,685. And this would be the equation, and then what you would have to do is you would have to solve for x. And what we would do here is we would subtract $425 from both sides. Right, that goes away, and we have that 6x is equal to 1260. And if I make a mistake, do please call me out. Class, nice and politely. We're going to divide by 6 both sides. That gets rid of that 6, and we get that x is equal to 210, I'm getting. So this is the amount of money, right, dollars, that you can spend on each door. Or, well, max dollars, if you don't want to go over budget. Right? And that's how you would solve this problem. Alright, so this was lesson 1.3, basically solving equations and writing equations. Please make sure that you review this and that you start working on your practice so that you're prepared and you're ready for your exam.